I'm Dr. K. Panda, working as Assistant Professor of Mathematics in Government City College, Nayapur, Hyderabad. Today I'm going to explain you about iteration method. So what is a fixed point iteration method? We'll call it as this as a fixed point method also. In numerical analysis, it is a method of computing fixed points by doing number of iterations to the functions. So we have two methods. One is open methods and other one is bracketing methods. We have already discussed about bracketing methods, that is bisection method and regular false method. These are all bracketing methods. Open methods are fixed point iteration method, Newton-Raphson method, secant method. Already I have explained in the previous videos about secant method and Newton-Raphson method. For these two, we don't need any brackets like this. Suppose we have chosen the two values a b such that f of a is less than 0 and f of b is greater than 0. We call it as bracketing methods. So this is we are doing in a bisection method and in regular false method. So these are called bracketing methods. So these open methods are we don't take values a b such that f of a less than 0 and f of b greater than 0. We don't consider signs here. So in open methods, those open methods are fixed point method, Newton-Raphson method, secant method. These two methods already I have explained you. So now we are doing about fixed point iteration method. So it is also known as one point iteration or successive substitution. So in iteration method, what we are doing is we have considered the given equation f of x is equal to 0. So given equation, we are calling it as f of x is equal to 0. What we have to do is we have to rewrite this equation f of x is equal to 0, rewrite this equation as in the form of x is equal to something, some x is equal to g of x. So the given equation is f of x is equal to 0. We have to rewrite this equation as x is equal to g of x. So f of x is equal to 0. Then rewrite this equation as x is equal to g of x. If we can solve g of x is equal to x, we solve f of x is equal to 0. So this x is known as the fixed point of g of x. We solve g of x is equal to x by computing xi plus 1 is equal to g of xi. So after rewriting the equation x is equal to g of x, what we will do is x1, that is g of x1, x2, g of x0. X0 is the initial approximation. X1 is g of x2, x2 is g of x1. Like that, we go on proceed the further iterations. So what is the general formula? Xi plus 1 is equal to g of xi. This is called iteration formula. Very simple formula, easy to solve. So what we have to do is whatever equation is given, write it in the form of x is equal to g of x. So take x side, left side, and so send the other terms to the right hand side. After that, what we have to do? Go on substitute. Let's take x0 is the initial approximation value. Go on substituting these values in this equation x is equal to g of x. If you substitute x is equal to x0, you will get x1. If you substitute x1, you will get x2. So on, continue the procedure, but you will get xi plus 1 is equal to g of xi. So you continue this procedure till you get the required result. So with x0 is given until xi plus 1 converges to x. So this x is your required root. So until you get the required root, you have to go on, continue the procedure. This is called iteration method, very simple procedure. I'll explain you. See, f of x is equal to x square minus 2x minus 3 is equal to 0. Okay, here I'm taking three cases. See, x square minus 2x minus 3 is equal to 0. X square is equal to 2x plus 3. X is equal to root 2x plus 3. So I am taking as what I said, take x is equal to g of x. So what is g of x here? Root 2x plus 3. So g of x is equal to root 2x plus 3. Next one, x square minus 2x minus 3 is equal to 0. X into x minus 2 minus 3 is equal to 0. X is equal to 3 by x minus 2. So what is your g of x? 3 by x minus 2. X square minus 2x minus 3 is, and all possible ways I am telling. 2x is equal to x square minus 3. X is equal to x square minus 3 by 2. So your g of x is x square minus 3 by 2. So here g of x is 3 by x minus 2. Here g of x is root 2x plus 3. Here g of x is x square minus 3 by 2. So three types of g of x you are taking. See. So in this one, I am taking the initial approximation with the 4. x naught is equal to 4, and go on substituting in this. Xi plus 1 is equal to root 2xi plus 3. That is your first case. See, this is your first case. So what is your g of xi plus 1 will become root 2xi plus 3. That is he is taking. See. So suppose take x naught is equal to 4. Substitute in this equation. Root 2 into 4 plus 3. That is root 11. You will get 3.31162. Again substitute this value here. So go on substituting this x value in the function root 2x plus 3. Okay, go on substituting your x value. Substitute first 4, that is root 11. Root 11 is 3.31662. Again substitute it. Root 2 into 3.31662 plus 3. So what is the answer? You will get 3.10375. Again substitute this value. So go on substituting. We are getting this. Up to 5 iterations we got this value. Next, take same x naught is equal to 4 and substitute here. 3 by 4 minus 2. That is 3 by 2, 1.5. Again 3 by 1.5 minus 2, minus 6. Again substitute. And you check the values. It is not at all converging. See, converging means you have to get the same, this sequence should converge to a value. But you observe here, it is not, it is converged, but it will converge very slowly. Up to some iterations, maybe you will get nearer to this, but it will converge, but it is very slow. Up to 8 iterations also, we didn't get a value. But here you see, x naught is equal to 4. Substitute in this. 4 square, 16 minus 3, that is 13 by 2, 6.5. Again 6.5 whole square minus 3 by 2, 19.625. Substitute this 19, 191. See here, this is 19, this is 191. So it is not at all converging to a value, so it is diverged. So you can't take x like this. Okay. See, for the same problem, I have chosen 3 different types of x. But what you observed is in the first case, it is converging. The second case, it is converged but very slow. But in third case, it is diverge. Next, find a root of e power minus x. X is equal to 0. So what you will write? X is equal to e power minus x. So what is your g of x? That is e power minus x. So what is the iteration formula? You will get xi plus 1 is equal to e power minus x. What is the initial value? He is taking 0. So e power 0, that is 1. E power 1, e power minus 1, you will get this value. Again e power minus 0.3, this one. Again e power minus 0.69, this one. E power minus 0.5, this one. E power minus 0.6. See, you go on. What you have to do, just substituting x value in this. Just go on substituting your x value. See, up to 10 iterations, almost you are getting nearer to your 0.5 value like that. Okay. So this is your answer. What is your root? 0.56. So go on repeating the iterations. Maybe this is your answer. 0.56714329. Go on doing the problems. Suppose some 12, 13 iterations, you will get this answer. Okay. So this is the root of f of x is equal to 0. Next. F of x is equal to x square minus x minus 2. Then fixed point of each function. See. So what is the first one? X square minus x minus 2 is equal to 0. From this, what we will write? X is equal to x square minus 2. This is one. One more thing is g of x is equal to x square is equal to x plus 2. So x is equal to root x plus 2. This is one choice. What is the other? What try all the chances? And one is x square is equal to divide with x. 1 plus 2 by x. That is one chance. And the other chance is g of x is equal to x square plus 2 by 2x minus 1. So these are the different choices we are getting for to find out the x value. These are all the 4 are, you can take any function and substituting the initial value, you will get a solution. Okay. So how many choices we can take, I am explaining here. After that, you know how to do. Just simply substituting, taking the initial value and simply substituting x value in these functions, you will get the solution. Next, for example, you have f of x is equal to x square minus 7x plus 3. So rearranging it, x cubed, sorry. So rearranging it, this is where the function we are getting is x is equal to x cube plus 7. So see here, f of x is equal to x cube minus 7x plus 3. So we are rearranging, we are getting x is equal to x cube plus 3 by 7. So this is the graph of your y is equal to, so f of x I'm taking it as um, y is equal to this one I'm taking it as x cube plus 3 by 7, and y is equal to x is a graph that is straight line. You can know that by intersecting this graph where you are intersecting, those are the solutions. See where we are, it is intersecting 2 point something. Both graphs are intersecting. Okay, just we'll see in this method how we'll get the solution. So let the initial approximation is 2. X naught is equal to 2, nearer to your root. See you in your figure. So nearer to this, nearer to 2 point something, we are getting root. So that's why he has chosen the initial value is nearing to the root. He has chosen 2 value. So substitute it. X naught place 2 cube 8 plus 3 11 by 7. So 1.57143. Again in the place of x1 you substitute this 0.98292. Again substitute 0.982 here. 0.56423. Substitute 0.56423. So on, you will get 0.454, etc. So on. The iteration is slowly converges to, suppose you do some more iterations, you will get this value 0.4441. So see here, I did some more iterations. So up to how many iterations you are getting, you see? 0.4542 here up to 4 I have explained you. Similarly, substitute 0.45423, you will get 0. In this equation xn cube plus 3 by 7, you will get 0.44196. Again substitute it 0.4409. Again substitute it 0.44082. Again 0.44081. So almost closer. So this is your root for x naught is equal to 2. The iteration will converge to the middle root alpha, since g dash of alpha is less than 1. So definitely it will converge. So which is converged to this value 0.44 something. So in the graph also you see this value nearer to 0.5 means some 0.4 something, this one. So it will converge to this value. That is he saying. Okay, in the graph also we can explain. With the graph also we can explain the root. Okay. So for suppose same the case, I have started the problem with x naught is equal to 2. But suppose you take x naught is equal to 3. See in the previous problem, I have taken x naught is equal to 2. For example, you have taken x naught is equal to 3. So you observe, suppose x naught is equal to 3. So 3 cube 27 plus 3 30 by 7. So you are getting this. Again substitute in the place of xn this 4.28571 whole cube plus 3 by 7. You got 11.6737. Again 11.6739 whole cube plus 3 by 7. 227.702. Again substitute this one. We are observing these values, you can easily say that they are diverged because you have chosen the value, initial value is 3. See, you observe in this figure. So this is your graphs. So near your root is near to 2. You have chosen the value outside far of 2. Here this is 3. Here you have taken here 3 value. So which is not at all near to your 2. Then what happened? You are getting a diverged solution. So depend upon your initial approximations, whether your solution is converge or diverges depend upon your initial approximation. So you should be very careful to choose your x naught. By choosing x naught only, the number of iterations will reduce. So how to choose this x naught? You have to choose this x naught very close to your root, not far away from the root. Okay, you should remember that. So for that he is saying some rule. You observe it. If x is equal to x star is equal to g of x star and g dash of x star is less than 1, then there is an interval containing x star such that the iteration is xi k plus 1 is equal to g of xk. So what he is saying that, so what is our procedure? if the given equation f of x is equal to 0, we are rearranging it and finding x is equal to g of x. So how to choose an value is x, some initial approximation is how to choose is you have to always choose the initial approximation with this formula. Mod g dash of x is less than 1. So what you have to do, find the derivative and substitute that value in this. If it is less than 1, if your initial approximation is satisfying this, that means you will x naught with that x naught you can get a converged root. Okay. So if g dash of some x value is greater than 1, the iterative scheme diverges. So if mod g dash of x is not less than 1, suppose mod g dash of x is greater than 1, if you choose x naught in such a way that then that does not converge and it will diverge. So asymptotic convergent root of fixed point iteration is usually linear with the constant c is equal to mod g dash of x star. If g dash of x star is equal to 0, the convergence rate is at least a quadratic. So finds the roots of the equation f of x is equal to x cube plus x minus 1, correct up to 2 decimal places. So f of x is x cube plus x minus 1. To find the roots of this equation, f of x is equal to 0, that is x cube plus x minus 1 is equal to 0. To choose the initial value, always you choose some interval. So by testing fa into fb less than 0, we estimated the root should be lies on 0, 1. You know how to get this interval. So 1 for f of a less than 0, f of b greater than 0. The product is less than 0. So we got some interval. So your root is lies between in this interval 0, 1. So you should first you should be careful with this. Next, there are many ways to change the equation to the fixed point form x is equal to pi of x using simple algebraic manipulation. My possible choices for phi of x is x is equal to 1 minus x cube. The other one is x is equal to, say, x cube plus x minus 1 is equal to 0. Easily you can say that x is equal to 1 minus x cube. That is your first one. Second one is x cube is equal to 1 minus x. X is equal to 1 minus x whole to the power of 1 by 3. Second choice. I have two choices. Then my question is, which one is better? You see. So previous theorem will suggest us which form of f of phi of x will converge reliably and rapidly so that we can able to reject that one which converges slowly. So taking the derivative of the above the forms. What is the first form? What is the first form? X is equal to, so your g of x is equal to, what is the first form? 1 minus x cube. What is the other form? G of x is equal to 1 minus x to the power of 1 by 3. You have two choices. So what is the previous theorem telling us? Always choose a initial approximation such that mod g dash of x is less than 1. So what is your g dash of first one? I have taken it as pi 1x. I have taken it as pi 2x. What is pi 1 dash of x? Pi 1 dash of x is minus 3x square. And what is pi 2 dash of x? 1 by 3 into 1 minus x whole to the power of 1 by 3 minus 1. So 1 by 3 minus 1 is equal to how much? Minus 2 by 3. So that I can write it as 1 by 3 by 1 by 3, 1 minus x whole power 1 by 3 minus 1, that is minus 2 by 3. So 1 by 3 by 1 minus x whole to the power of 2 by 3. Okay. So you have two chances. Pi 2 of x is okay, n into x power n minus 1. 1 by 3 into 1 minus x whole to the power of 2 by 3. Okay. So you have two chances. So by substituting x is equal to 0.8 in this one, first one we are getting greater than 1, second one we are getting less than 1. That means what? Which one you have to choose? Which function you have to choose? Pi 2 of x. So reject pi 1 of x and choose pi 2 of x. So testing the value of x is equal to 0.8 and putting the above equation in taking the absolute value of it, we get this one is greater than 1 and this is less than 1. Since pi 1 dash of j of greater than 1, we reject pi 1 of x and we choose pi 2 of x for this iteration. So what you have to do now? What is your pi 2 of x? Your pi 2 of x is 1 minus x whole to the power of 1 by 3. So take pi 2 of 0.8. Then you will get 1 minus 0.8 whole to the power of 1 by 3. So nearly some 0.5848 like that you will get. You go on substituting values 0, 3, 5, 4, 7, 6. If you substitute this value, suppose you take it as this is x1, your x1 is 0.5848035476. Then substituting this value in this place of x, you will get 0.8362511031. Go on substituting this value. Some x3 is 0.519080, like that. Go on some 7 to 8 iterations, you will get a solution 0.9999, like that. That is your solution. Okay, so repeat the procedure till you get the desired accuracy. So when the problem is given, what you have to do, take all possible combinations for your x and take some initial approximation and substitute it and check whether the derivative is less than 1 or greater than 1. If it is less than 1, then the root will converge rapidly. So see the next problem, x square minus x minus 1 is equal to 0. So I am taking at the iteration 1 is x square is equal to 1 plus x and your x is 1 by x plus 1. So your iteration formula is xi plus 1 is equal to 1 by xi plus 1. I'm starting with the initial value 2. How to get the initial value? You always choose an interval and so take a mid value of that, then easily you can get. So x1 is equal to 2, x2 is equal to 1 plus 1 by 2, 1.5, x3 is 1 plus 1.5, that is 1.666, x4 is 1 plus 1 by 1.666, that is 1.6. Like that you go on repeat the procedure. So this is about iteration method. So what is iteration method? You know iteration method, what you have to do. So I am just recollecting you. So if any equation is given, what is the first step you have to do? Write in the form of x is equal to g of x. And after that, what you have to do? Take an initial approximation. After that, what you have to do? Always check mod g dash of x naught is less than 1 or not. If it is less than 1, easily it will converge. Okay. And after that, after choosing initial approximation, what we have to do? What is your x1? G of x naught. What is your x2? G of x1. What is your x3? G of x2. So what is your general formula? Xi plus 1 is equal to G of xi. So this is your iteration formula. So go on, do the procedure till you get the required result. So this is about fixed iteration method. This is very, very easy method. The only thing you should be careful is how to choose x naught and how to choose x is equal to g of x. So this is the procedure to choose fixed point iteration method.